Hello again, it's time for lesson 12.4, shapes of distribution. So more about distribution. We're going to look at another kind of graph called a histogram. We have talked a little bit in class about what a histogram is. It's basically a bar graph where the bars touch, and it shows the frequency of data values in intervals of the same size. So on your x-axis, you're going to have number ranges instead of categories. And because they are number range and one goes from right into one from the next, that means that they touch because the data is continuous. It's another useful display that shows the shape of how the data is distributed. So just like with the box and whisker plot, we had skewed left, symmetric, skewed right. We can look at a histogram the same exact way. So here's a histogram here. And this represents data that is skewed left because the tail of this data is longer, and you can kind of see that it looks like most of the data is pushed over to the right here. So skewed left means the tail of it is longer than the tail of the right. Symmetric data, again, both tails appear to be the same, and the middle appears to be in the middle, like a nice little bell curve. And data that is skewed right in a histogram, you can identify it because the tail on the right is longer. So it's not that all the data looks like it's over here, it's the length of the tail. So skewed right, the data extends to the right. Most of the data is on the left. So kind of like a box and whisker plot, right? Except the tail is actually where these bars are kind of decreasing there. Alrighty. So why do we need to know about the shapes of the distribution? Well, the shape of the distribution can be used to choose the most appropriate measure of central tendency that describes the data set. I was talking in class about if everyone got 100% and I had on a test and somebody didn't take their test and I loaded it in as a 0, that outlier is going to kind of skew the results of the data. So you have to determine, how should I measure what the average is? Should I use the mean? Should I use the median? Which one's best? And same thing with range. If we have outliers and we're just taking high minus low to find the range, that's not going to give us a really good idea of what the range actually is. So it would be better to use standard deviation. So that's what we're going to talk about with this, to know which measure of central tendency and which measure of distribution you should use based on what the graph looks like. So start with symmetric. If you have a symmetric distribution, so the tail's same length, the median, the tallest bars appears to be in the middle, the mean and the median will be about the same, although the mean should be used to describe the center because the mean's going to include all of the values. The median's just the one that's in the middle, the mean includes them all. So when you see symmetric, use the mean. When a distribution is symmetric, use the standard deviation to describe the spread of the data. So if you have symmetric, we're going to use standard deviation to describe the center. So again, both of these, you're using all of the values in the data set. When you have a skewed distribution, meaning it's skewed to the left or skewed to the right, the mean is going to end up in the direction that the graph is skewed, while the median is going to be less affected. So if you see that the data are skewed, they're not symmetric, you're going to want to use the median instead. Also, when the distribution is skewed, you'd want to use the 5-number summary to figure out the distribution of the data. So that 25% in each whisker, the 50% in the middle, you can kind of look at it like this as well. So you'd want the 5-number summary to give you the distribution instead of just having the standard deviation. That's going to give you a more accurate picture of it. So skewed data means median and 5-number summary. Symmetric data means mean and standard deviation. So let's look at a couple examples here. Turn your page. It says, which measure of central tendency and dispersion best represents the data? Explain. Well, in looking at this graph, if I were to kind of draw a curve around it like this, do you see how this tail is so much longer than this one? This data on the right side has a longer tail. That means that this is skewed right. So go ahead and write skewed right so you know why you're answering what you answer. we said that when the graph was skewed, that we were supposed to use for central tendency. Do you remember which one? Skewed right or skewed left means that we should use the median instead because our mean is going to be thrown off. So you would use the median as a measure of central tendency to figure out what's the middle of this data, and to figure out how the data is distributed or the dispersion of the data. When it's skewed, we said that we use the 5-number summary. You don't have to figure those out at the moment. I'm sure we'll do some of that in class, but those are the measures that we would want to give us the most accurate idea of what this data is telling us. When you look at example 2, here's the middle, there's tail 1, there's tail 2. Those appear to be about the same length to me, and here's the middle of the data. So I would call this one symmetric. And we said when the data is symmetric that we use for central tendency, we can use the mean. We should use the mean. And we should also use the standard deviation for that. Instead of the 5-number summary, if it's symmetric, you're going to use standard deviation. So far, so good? Okay. Scooch it on over. The application portion. Whew! Always the trickiest. I know you probably get overwhelmed when you see giant tables like this, but tables are great for organizing our information, so don't be nervous. Take a look here. It says a police officer measures the speeds in miles per hour of 30 motorists. So 30 people driving by, that means there's 30 values within here. And the results are shown in this table. I don't know about you, but when I look at a table with a bunch of numbers mixed up all over the place, it doesn't really give me any idea of how fast people are going. It's really helpful if you can organize your data. Now, maybe you want to start listing all of these data values and see how many people were going how fast. But honestly, there's not a ton of repeating values in here. I can kind of see that. This is where a histogram would be appropriate to give ranges, because I might want to say, well, they were traveling in the 30s or in the 40s or in the 50s. I give you 6 spots here, and I think going in ranges of about 5 miles per hour would be great. So to figure out how to set up these intervals here, these ranges, you're going to want to identify what your lowest value in the data set is and what your highest is. And looking, it looks like the 30s are the lowest, and my lowest value is a 32. And as far as the highest number, I see I have a 60 here. 60 appears to be the highest. So I need to get from about 30 to 60, and I have 1, 2, 3, 4, 5, 6 lines here. Okay, so 6 lines. I need to get 30 miles per hour in there. 30 divided by 6 is 5. I'm going to go in intervals of 5. Now remember, these need to be the same size. So I don't want to start with 32. I do want to be able to end at 60 though. So my first range of numbers, I would use our 31 to 35. So that represents anybody going 31, 32, 33, 34, or 35. There are 5 values in there. The next range would start at 36. And if I'm including the 5 values, it would be 36, 37, 38, 39, and 40. We can continue going now. 41 to 45, 46 to 50, 51 to 55, and 56 to 60. Look at that. It works out perfectly. Almost like I planned it that way. Yes, of course. Well, I did receive this book or this example from the book, so the book planned it this way. I'm always happy when that happens. Okay, so in trying to figure out the frequencies now, honestly, I think the best way to go to start would just to use tallies and to list the numbers at the end. So what I would do is I would take number by number and tally where it goes. So 32 would end up right in this box. I'm going to cross it off. 53 would be down here. 56 would be here. 50. So you do this while I do this, just like we're in class, and hopefully all of our answers will match up at the end. I have to cross off as I go, otherwise I know I'm notorious for missing things. I just do stuff too fast. There we go, 50. So you keep going. And I don't mind working through this on a video notes lesson because this is exactly what you would need to do in real life with your homework assignment. You'll get problems like this and, well, how on earth do I even begin to set something up for this? This is how you do it. So it's nice to have the thought process through it all. There's a 42, 55, 49. Good times, good times. 55. There's a lot in this range. 60, 47. Okay, so I finished all my tally marks. Now instead of the tallies, I think I'd like to just write what the actual number is right next to it if you don't mind. So for the 31 to 35 range, we have 1. For 36 to 40, we have 4. 41 to 45 is 5. 46 to 50 range is 5. 51 to 55 range is 11. And 56 to 60 range is 4. This is funny. This was all, they're measuring their speeds in the same place. And we've got a lot of different speeds going on here. Okay, now our job is to take this and we're going to put it into a histogram. And the reason we're going to do that is so we can see how the data are distributed. We want to know, is it skewed left? Is it skewed right? Is this data symmetric? Maybe some of you can tell just by looking at that. It's still really good practice to put it into a histogram. So in a histogram, I'm going to have an X and Y axis. So I'll kind of bold those in. And down here, this is where we put our speeds in miles per hour. And I'm going to list our ranges. So I have a 31 to 35. We have a 36 to 40. 41 to 45. 46 to 50. 51 to 55. And 56 to 60. X-axis, all set. On our y-axis, we have the frequency. So I'm going to go ahead and write frequency. How many times it happens. That's what frequency means. And when I'm looking at my y values in the table, it looks like my lowest is 1 and my highest is 11. So that means on my number scale, I need to be able to get all the way up to 11. I can see I don't have enough lines to count by 1, but can we count by 2? 2, 4, 6, 8, 10, 12. Wow, that works out perfectly. We can count by 2s. So this is 0. Each line is 2. All right, now it's time to fill out the bars. So for the 31 to 35 range, I see that the frequency is 1, so I'm going to go halfway through, do my best to go halfway through, and draw that bar. I'll shade this one in so it's a little bit easier to see for you. And the next 36 to 40, it says 4 motorists. So let's go up to 4. And I'll shade that one in as best as I can. I'm not going to make it perfect. I can let it go, right? So we can finish this note set in under half an hour. Whew. 41 to 45 says it happened 5 times. So I'm going to go halfway between. There's my bar. And again, they are touching because it's continuous data. 40 rolls right into 41. 46 to 50 is also 5. Shade that in. Okay, 51 to 55 is 11. So I'm going to go all the way up to 11, halfway between the 10 and the 12. And last but not least, the 56 to 60 range is 4. So there's our 4. Okay, so there's our little histogram. It's a nice visual of what our data says in that table. I don't know about you, but looking at this is a little bit easier than looking at that hot mess, right? That's just, everything's everywhere. This is nice. When I look at this, I can tell that it's skewed in which direction. What do you think? If you're having a hard time, draw the line above the data. Here's the peak of the data. Do you see how this tail is way longer than this one? That would mean that this data, because the left tail is longer, is skewed left. So my question for you is, which measures of central tendency and dispersion best represent the data? Well, when you have data that is skewed, do you remember which central tendency measurement you're supposed to use? That's right. You should definitely use the median. So we're going to use the median because it's skewed. And the measure of dispersion, is it standard deviation or is it 5-number summary when it's skewed? You're going to have to memorize that one eventually here. So we're going to use the median for central tendency, and the measure of dispersion at best when it's skewed is the 5-number summary. So skewed, that means median, 5-number summary. Okay, and both of those are kind of the easier ones if you think about it. The mean and the standard deviation, those two that go together, those take a little bit longer to calculate than these two. All right, last but not least, let's kind of interpret what all this means here. It says the speed limit is 45 miles per hour. How would you interpret these results? So we're looking here, and this was the same spot that the police officer was observing the speeds of motorists. This is my speed limit right here. It ends at 45, right? So do you see how most of this data is to the right of that, is greater than that? Do you know what that means about these motorists? It means that a lot of people were speeding. That's what I would say. A lot of people were speeding. I'm not sure if they just observed how fast they were going or if people actually got pulled over. I'm guessing a couple people got pulled over that day. I'll see you tomorrow.